Hello guys, after long back today I'm uploading this video, and in previous videos we have learned some basic concepts and few things about BGP and EAGRP. Before start watching this video, if you want some idea about BGP, please go and watch my previous videos. And in this video we are going to see why the next stop self command will be useful while doing the BGP configurations. And this is a scenario what we are going to look into today. So here I'm having router 1, router 2, which is in AS100, and router 3 it is in AS200. Here my objective is simple. From R2 I should reach the R3 loopback interface IP address using BGP. Here only I'm going to do the BGP configurations in all these routers, and between R1 and R3 it will be the eBGP or neighbor. Yeah, so sorry for that. And between router 1 and router 3 it will be forming a eBGP, and router 1 and router 2 will be forming iBGP. Why? Because router 1 router 3 in different AS, or they are trying to form neighbor relationship, so it will be eBGP. And router 1 and router 2 they are going to form the iBGP. Why? Because they are in the same AS, which is called AS100, and the IP address I have given. Now let's go and start configuring. So we'll come to know what is the issue we will be facing, and how this reachability that we can make it successful. Yeah. Okay, so I'm going to start configuring with router 1. In router 1 I have two interfaces. Interface fast ethernet 0/0, IP address 10.0.0.1, and here I'm using /8. And then interface fast ethernet 2/0, IP address 20.0.0.1. No shutdown. Enough. First we'll I'm very sorry, I have done this configuration router 3. Sorry. Interface fast ethernet 0/0, no IP address. Interface fast ethernet 2/0, no IP address. Okay. In router 3 we have two interfaces, fast ethernet 0/0, IP address 10.0.0.2 255.0.0.0, no shutdown. And one more is interface loopback 0, IP address it is 192.168.0.1, it is class C. Okay, now I have done in router 3. So let's do interface configuration router 1. And one more interface fast ethernet 2/0, IP address 20.0.0.1 to 55.0.0.0, no shutdown. Exit. I have done in router 1 also, and in router 2. And what is that interface 2/1, and IP is 20.0.0.2. so interface fast ethernet 2/1, IP address 20.0.0.2 to 55.0.0.0, no shutdown. Exit. Show IP int brief. See here I have configured single interface in router 2, and let's verify in router 1 and 3. To interface 10.0.0.1, and 20.0.0.1 in router 3. One it is fast ethernet 0/0 10.0.0.2 and one it is loopback interface. Fine. So let's go and start configuring with BGP. And what is that command? How to enable BGP? Router BGP, and the autonomous system where the router 1 is sitting is 100. Here now we need to tell R1 has two BGP peers. One it is with R3 and one it is with R2. So we'll start telling that in commands neighbor 10.0.0.2 and the remote AS of R3 it will be 200 and neighbor which is R2's IP address is 20.0.0.2. Okay, so 20.0.0.2 remote AS it will be the same AS which is 100. Fine. So we have done with R1. Let's go to R2. Configure terminal router BGP 100. For R2 there is for R2 for R2 there is only one neighbor which is R1. So it is 20.0.0.1 which is the other end of that connecting interface for R2 which is connecting to R1, and remote AS it will be 100. That's it with R2. Let's go to R3. Router BGP here in R3 it will be 200 and R3 having only one BGP peer which is with R1 10.0.0.1 remote AS it will be 100. Let's wait and watch. So my adjacency has been done here. BGP neighbor has come up. Show IP BGP summary. You can see the peer which is with router 1, and router 1 it should have two peers, one with R3 and one with R2, and router 2 should have one peer. Yeah, so if you go and see the routing table of router 1, show IP route BGP, it's nothing. It started learning from BGP, and in route it is having only directly connected and locally connected. Why? Because till now we didn't advertise any of the networks inside our BGP. Okay, so our objective is that from R2 I should able to reach the router 3's loopback interface. So what I need to do in router 3, first I need to advertise my loopback IP that particular network into the BGP. Let's go and do that. So in router 3 router BGP 200, the network what I'm going to advertise, it is not an IP address, it is a network address. You should be very careful. 0.0 and mask it will be and one more thing I need to tell you in this BGP. Here whenever you are advertising some network, it should exactly match what you have configured under the interface. For example, here I have configured the mask with /24. Here if I'm trying to advertise with /16 or /8 which is not 24, then BGP will not advertise that particular subnet or prefix. I will show you now. Instead of 24 I'm just giving here 16 as a mask. Let's go and verify it whether it is advertising or not. Show IP BGP neighbor 10.0.0.1 advertised routes. See, this is a command to verify for this peer what the router 3 is what are the routes router 3 is advertising to R1. To check that status, this is a command we need to use. it is not yet advertised. Even if you can go and see in BGP table, nothing is there, nothing is there, nothing is there. Let's, what we can do here now, let's go and advertise properly. From R3, instead of /16, I'm going to advertise this as 24. So router BGP 200, no network 192. First I'm going to remove that what I have advertised previously, mask 255 0.0. So I'm going to advertise newly .255.0. Okay, let's verify it now. See here, now for that command I'm getting some outputs. Show IP BGP neighbor, the particular peer IP and advertised routes. So it is advertising 192.168.0.0. Okay, and here you can see something called next hop. Actually it is something you need to learn in BGP. Wherever you are seeing next hop is 000 in BGP, that means it is origin from the same router. So it is there is no need of next hop to reach this particular subnet, because it is already locally uh, how to say that, oh yeah, it is locally within that router R3 only. It is not anywhere to go and reach that particular subnet. It is not like that. Fine, I think you are clear with this concept. Fine, and let's go and see in router 2, router 1, I am receiving that IP. Show IP BGP. So inside BGP I am getting the star and some greater than symbol you are seeing, right? The star is nothing but whether the subnet is valid or not, it will tell. Okay, and this will indicate you whether this is the best path. For example, if I have multiple paths to reach this single network, you'll see in coming videos, here I'm having only one path to reach this, so this path is valid and it is the best path. It is telling in my BGP table. So from R1, my next stop it will be 10.0.0.2, which is the router 3 interface. So from R1, if I want to reach that particular loopbacks, this 192 network, then I need to reach my next stop, which is 10.0.0.2. Okay, and let's go and see in router 2, show IP BGP. In BGP table I can able to see, okay, 192 network, but it is only telling me it is a valid, but it is not the best path. So what happens when I try to reach 192.168.0.1? I can't able to reach it. But if you go to R1 and if you try to ping 192.168.0.1, so from R1 you can able to reach this particular loopback, but from R2 you are not able to reach this particular loopback. How it comes? Actually, this is a concept here. So even R2 can able to see this 192 network, 192.168.0 network, but even R1 can see, but R1 can ping, R2 can't able to ping. The thing you are seeing in R2, the next stop is 10.0.0.2, correct? So whatever R1 received, the route update from R3, R3 is telling, now R3 is telling to R1, if you want to reach this loopback, that is 192.168.0 network, come to me. Okay, now R1, what he is telling to R2, hey R2, if you want to reach this 192.168.0 network, your next stop is going to be 10.0.0.2, where R2 does not have visibility on this 10.0.0.2. Why? In the sense, R3 didn't advertise that network, one thing. Okay, it is not must. Okay, when it is ISP or enterprise connection, uh, they don't want to advertise their networks. Okay, so it can be one thing. Otherwise, R2 does not know where this 10.0.02 is located, so he can't able to reach this particular 192.168.0.1. So what R1 should do, R1 should do, R1 should tell R2 that you can reach this network via R1 through him. Why? Because R1 know this 10 network. Why? Because he is directly connected to the network, so he can do it. So so what we need to do, so that R1 will tell to R2 he is the next hop for reaching the router 3's loopback interface. There is nothing but much configurations and all. It is just a single line. You just go to the router configuration, router BGP 100, and for which neighbor you are configuring now, you are telling that router 2 configurations, that is neighbor 20.0.0.2 next hop self. This a command will tell R1 whatever you are advertising to R2 or to any of your iBGP peers, make you as the next hop self. That means you are the next stop for the networks whatever you are advertising. Okay, so in this case he is advertising only. In this configuration we are telling, so whatever the routes you are updating to the neighbor 20.0.0.2, make yourself as a next stop, so that he can reach that particular subnet. Now you can see in router 2 where it is, show IP BGP. And here one more thing we need to do actually, and we advertise this loopback network to R3, and even just a minute. So we didn't advertise this 20 network between this router 1 and router 2. So why it is necessary? For example, when I'm trying to ping from R2, my packet will reach R1. From R1 it can reach router 3, and from there it can reach loopback 0, right? So once actually when we are speaking about ping, it is a bidirectional traffic. That means echo request and reply will be coming. So whenever the echo requesting is going by R1 and reaching to R3, from there it is reaching loopback 0, my echo reply should come back to R1, from there it should come back to R2, correct? So R3 should know something about this 20 network. So when he will come to know about the 20 network, only when I start advertising it. If I'm not advertising it, R3 will not come to know about the 20 network. So we'll just go and advertise the 20 network, router BGP 100. You should be very careful while advertising the 20 network. Here we configured as a /8 network 20.0.0.0 mask 255.0.0.0. Okay, see here now, enter R2, I got the route, best route for 192.168.0.1. Now I can able to reach. But if you see in past scenarios, past attempt to ping to that particular network, it was unsuccessful, right? So when I start at so here only the thing I did, only two things. What I did, I went to router 1, I told whatever you are updating to the router 2, which is your iBGP peer, the update what you are doing, sorry, whatever the routes you are updating to R2, you make yourself as a next stop self. Why? Because R2 does not have the visibility to 10 network. Okay, so that attempt give us a one successful point. And the next one what we have done here, it is here this network we have advertised, but we didn't advertise this network. You should be very careful. For example, if you are thinking it is a ISP, Okay, or for example, I am telling if it is an enterprise network. Okay, so ISP is giving connection to you. It does not mean that ISP need to advertise their network on your end. Okay, here nowhere we have advertised this 10 network either in R1 or R3, right? Only we have told R1 for in R1 we have told that R3 is your eBGP peer, and from R3 we have told that R1 is your eBGP peer. That's it. But only the thing we advertise this 20 network so that R2 will get the reachability to this R3 loopback interface. Even from R3 I need to show you one thing. From R3 if you try to ping 20.0.0.2, it won't ping. You can check in its route show IP route, right? See here, you already known about this 20 network via 10.0.0.1, right? But still you could not able to reach. And from R1, why? Because you go to now R2 and see his routing table. Okay, the interesting thing is you are not seeing any 10 network here. Why? Because when you are trying to ping from R3 to R2's interface IP address, anyway we don't have any media to come here. Anyway it need to cross this 10 network, but R2 does not know about any 10 network, so directly it will discard the packet whatever it is getting. But from R3 if you try to ping the same 20.0.0.2 and as a source 192.168.0.1, it will ping. Why? Because in R2 table you can see the 192.168 network. So by default when you are pinging from R3 as a destination IP 20.0.0.2, the source IP by default it will be taking as a exit interface IP. So in R3 exit interface IP is nothing but 10 network, which is not known by R2, so that particular packet is discarded. If the same thing, if I try ping the same IP 20.0.0.2 with the source IP 192.168.0.1, it is successful. And friends, thanks for watching. If you like this video, please like and subscribe it. We'll see you in coming videos. Bye bye.